also some examples of IoT related applications in healthcare. One is IoT based mobile health application, another is IoT based remote patient monitoring. So in IoT based mobile health application, you can see here nowadays people use several wearable devices, uh, ring, smartwatch, um, also uh, smart pendant, the locket, and they collect data, and those data can be sent to the handheld device such as cell phone, or using maybe Bluetooth or NFC, and then the health application sends application data to cloud through IoT gateway. That could be also a mobile device. And you can see here in this way the wearable device, which are the IoT devices, we can say, they collect data and transmit data to the data center through intermediate like the cell phone, or some we can say that is the IoT gateway. Another part is IoT based remote patient monitoring. So in IoT based remote health monitoring, we can also put some IoT based devices. If a patient is at our home, then different IoT based devices such as wearable sensors to monitor the blood pressure, to monitor the blood sugar, uh, the different components, mm, can be the health components can be monitored using wearable devices, and those devices can transmit data through a gateway. Maybe it could be Wi-Fi access point, or it could be a mobile phone, cell phone, and then that data can be transmitted to the um, sorry, to the cloud data center or the fog data center. And then the if any after analysis, if any abnormal data found, that abnormal data, um, after the analysis it is found, then that data can be reported, can be sent back to the family members or to the doctors, we can say the responder, and then the patient can be taken care even if remotely. So IoT devices plays very important role, as well as the cloud. And in between IoT cloud, there are so many things that is related to communication, and also the data analysis plays very important role. So we can say here the unpredictable amounts of heterogeneous data is generated by IoT devices. So it is, there are lots of research issues we can see, because heterogeneous data are generated also in healthcare management or in industrial applications. So okay, we can say here I have mentioned the drawback is delay due to data transmission. In this case, in the health application, the delay due to data transmission is very important. So latency plays very important role, and it can be one of the research issue. So another part of the IoT research issues, we can say that the smart city. So in the smart city, there are different IoT devices. I have mentioned their like the specifications, like normal specifications such as the processor, storage, battery power, and type of data normally they generate. As you can see here, these IoT devices, which are used in the smart city, may generate text, image, audio, video data, and can be transmitted through different devices such as the vehicles. This is what we say VANet, vehicular ad hoc network, and also through drones, or through smart glasses, smart specs, smart watches, and also through mobile phone. And data generated, the after the data generated, the important research issue is, we can say here, the power consumption. because these devices sometimes they don't have enough power. So computing resource is also another research issue in these devices. So we can see in the smart city. I am giving here different um, giving here an environment related to the research issue. So it could be autonomous driving. It generates lots of data. It could be artificial reality, it could be virtual reality, it could be disaster management, and we may use the smart home appliances or smart vehicle or smart device or smart drones or mobile phones, as I have mentioned earlier. And those IoT data can be transmitted to the remote cloud data centers. And in this case, the latency, bandwidth, power consumption, mobility, these are the limitations, so we can consider them as our research issues. Let us talk now related to fog and cloud computing. Since this topic is like very generic, it's IoT, cloud computing, and then data analytics. So that's why I am going to introduce just basic concepts related to this topic. So if we say it's a fog and cloud computing, we can have several mobile users, and we can consider them. Each mobile users may have also multiple IoT devices, not necessarily a single IoT device. May have one mobile user may have multiple um, IoT devices, and those devices, when they generate data, that they can transmit data to the cloud computing environment, which is a centralized system. And and then we can see, the if we analyze the whole system, the fog computing comes into picture other than the core computing. Normally, the cloud computing, which is considered as the core computing, then the fog computing uh, is considered as a distributed computing environment. Since the cloud is the centralized system, so the fog computing environment can be created in a smart city at a different locations, and a highly virtualized platform to extend the cloud computing to edge of the networks. So the IoT devices can be considered as also the edge devices. When they collect data, they can transmit, instead of transmitting directly data to the cloud computing platform, they can transmit data to the fog computing environment. And if it is the local data, maybe analyzed, if it is necessary, maybe again transmitted to the core computing platform, as you can see in this example. So the computation, critical data storage, and networking services are performed locally, that is in the fog servers. So the local, the like social requirements, publicity, sales, machines, product information, logistic, and some industrial information. So those data, instead of transmitting to the cloud computing platform, could be transmitted to the fog servers. We can see here the complete picture of the IoT devices, the fog servers, as well as the core platform, the cloud computing platform. In this example, as you can see, the different mobile users with the different applications, then they can transmit data to the fog nodes, and then to the cloud platform. So the fog nodes, normally they are flexible and could be scalable, and they are also adaptable. Now we can see the research issue in the fog computing. So some part of my research I have mentioned here. I will not go into details related to the mathematics, but I'm just giving here an example how we can analyze in the fog computing environment, how we can use different mathematical models, such as for the power consumption, we may design the model in order to design a delay model. So the network delay between the network delay between mobile user to the IoT gateway, or network delay among different mobile users. And we can also calculate the total computation delay of the mobile application task. And another part is the related to power consumption. Also, we can calculate the power consumption for the fog nodes power consumption, like for the 0% power consumption, 100%, and resource utilization of each individual fog node at time t. So we can calculate it taking it as function of time, the power consumption. Or container migration also can be modeled in the fog computing. So when the user moves from one point, one cell to another cell, one spot to another spot, so the fog computing, normally the fog computing platform is static. Of course, we can also consider I said like mobile. Normally it is static, but the users are mobile. So when users move from one cell to another cell, then the container needs to be migrated. So that also can be modeled. So I'm just giving here some part of the research issues and the models as example. It is not necessarily only delay, power consumption, container migration. We can also think about data uploading, the latency for data uploading, data downloading, and also related to the service time analysis. There are different research issues. Of course, we need to read different articles and find out our own way the new concepts. Then the next part is related to okay. So yes, here we can say how to minimize the cost of power consumption, delay, and container migration. Maybe we can use the linear programming problem to minimize the cost of power consumption, delay, or container migration. Then this fog computing model, as we can see, the one is we can consider the device layer. Device layer for the Internet of Things device. Those devices are fitted maybe in smart home, smart city, smart hospital, so at different locations. And we can consider location 1 up to location n number of locations, and we can have like m number of devices. And even if in location 1 we can have suppose 100 devices, location 2 maybe we can have 200 devices, not necessarily sorry, same number of devices, we can have different number of devices. And also we can also consider the devices those who can generate heterogeneous data, and those data can be transmitted to the fog nodes, that is the virtualized data centers, and we can use data mining techniques and to make the to develop the decision making algorithms. So we can consider here the one is a device layer, another is the fog layer, and the the core computing platform as the cloud layer. So it is very interesting, related to communication, related to data mining, related to data virtualization, related to resource management, related to data classification, related to pattern analysis. Different areas of research can be included in this computing model. So the fog computing based system model, what I have mentioned earlier in the previous PPT, in previous slide, that we have the users layer and the fog layer and the cloud layer. So in between the fog and user layer, different communication methods could be used, such as GPRS, Wi-Fi, 4G, 5G, 6G. Nowadays, people are also focusing research on 6G. So the different research issues also can be thought based on the number of IoT devices, based on their mobility, based on their capacity, based on their capability, and based on the type of devices. So how communication can be done, and the fog nodes, maybe it is fog devices for the smart home application, or fog devices for the smart city application, or fog devices for the smart healthcare applications. The different applications also could be considered as the research issues. Okay, let me skip this one. So we can consider here the layered architecture of this fog computing system model. Could be the cloud storage layer, and then the decision making layer. If we go from the bottom, then I will say the data acquisition layer, that is by the IoT devices, and then next to that, event classification layer, then information mining layer, then decision making layer, and then cloud storage layer. In this way, that is bottom of approach if we consider. And the applications could be hospital, could be family network, or could be the users, responders like doctors or the ambulance. So in different applications, as I have mentioned earlier, we can use it. Now the research issues in fog computing, important research issues we can consider, like the bandwidth, memory, storage, and CPU. So I have compared here. The blue color indicates the resource for the bandwidth resource for the fog computing. Red indicates for the cloud computing. As you can see, the bandwidth, memory, storage, CPU, the processing capacity of the fog computing nodes is normally very less as compared to the core computing nodes such as cloud computing. So it needs it needs efficient fog resource utilization models. And for the mobility in fog computing applications that are uploaded to near edge fog nodes, so resource management, task management is also an issue in this distributed environment. So we can say the important research issues in fog computing is the resource utilization, to design resource utilization models, or to design the task management models. If we consider if we combine the Internet of Things, fog or and cloud computing environment, the concept of cyber physical system comes. I'm just introducing some part of it. I find this course is related to this workshop is related to industry 4.0 cyber physical systems. So I am introducing few slides here related to that. So as we know, cyber physical system, they are enabler. Cyber physical systems are enabler for the new era of real-time internet-based communication and collaboration among value chain participants. And the devices, among devices, the systems, these devices normally in the physical cyber physical systems are very important. So we can say the one is the physical system, another is the network technology, and the cyber system. So cyber physical system, if we can see here, the physical system is such as like the smart healthcare or smart hospital, smart home, smart city. So where IoT devices plays very important roles. And then the cyber system, where we can have the fog nodes or the cloud computing environment, or we can say both fog and cloud computing environment. Of course, in between physical and cyber systems, the network technology plays very important role, which could be Wi-Fi, could be Bluetooth, could be Zigbee, could be 5G, 6G. network. So in cyber physical system, I'm going to give you one example of one application example related to the healthcare. So related to, of course, my research. That's why I thought to put this as an example here. Epilepsy is a neurological disorder. As here it's several million people are normally affected globally in epilepsy, and we can use also cyber physical system to monitor this one. So epilepsy seizure, we can see here if it's a normal activity, and when epileptic attack occurs, so then it could be the seizure, could be unusual behavior, could be sensation, could be unconsciousness, could be staring. And we can use IoT devices here to monitor different parameters, such as the body area sensing network. So we can use EEG to detect this epileptic seizure. So in this example, what I am showing, the EEG can collect data. EEG can have more than like 100 electrodes, can transmit 1000 samples per second, and each sample size may be 2 bytes, and with data rate 1.6 mbps. And in every 10 seconds or 5 minutes, we can define that. Then it can be transmitted to the PDA, and PDA can analyze the epilepsy current situation. But the PDA, it has the drawback: this mobile edge device can have limited resources or processing capabilities, reliability, power consumption. These are also problems in this application. So in conventional method, what we can do, that after collecting data through the PDA, that data can be also transmitted to the medical health cloud, and then data can be analyzed in the medical health cloud to give the feedback. So another example also, which is also I feel very essential for the India, is the mosquitoes. So as we know, there are different diseases because of the mosquito bite, and we can use also the IoT devices to collect data. We can also put different devices in our body, that is body area network, we can say. It's a band. So those IoT devices can be fitted into the body, and through the mobile phone, as mentioned earlier, can be transmitted to the cloud. But the issues are like high latency. So so how to minimize the latency could be one research issue, and mobility management could be another research issue. Scalability also another research issue. Location hour service provider could be another research issue. But the merits for this fog-based IoT healthcare data is it can consume less energy, and the location awareness, data preloading, scalability. If we can solve, of course, so we can get these benefits. Then the application for the cyber physical system, as I have mentioned, one is the physical space, another is the cyberspace. So for cyberspace, we may have the fog computing, cloud computing, and also the edge computing, end users. And in the uh, mm, physical space, we can collect like the personal detail data collection. So I'm coming to the data part, such as the mosquito counts, the breeding sites. So those are the physical systems, and from those physical systems data can be collected. I'm not talking about communication system. Then we can transmit data to the cyber system in order to create the cyber physical system. And in also industrial cyber physical system, similar way, in industry, the different sensors, IoT devices can be fitted into different machines. They can collect data and then transmit it to the cloud computing environment, what we say big data. Then the supervisory control terminals could be there to monitor the different machines. So in industry, 4.0, I'm just showing the basic concept for this industry 4.0 evolution, that is from industry 1.0 to 2.0 to 3.0 and currently to in industry 4.0. I would like to mention here why, because IoT and cloud computing play very important role in industry 4.0. So we can see here in this example that in industry 4.0 how the industrial devices are monitored. So it could be the robots, or the like the could be smart automation, or it could be intelligent edge devices, or could be smart mesh for industrial applications. So in the real time basis, the data can be collected and the devices can be monitored. And we can see the role of cyber physical system in industry 4.0. The If we divide it into two parts, the physical system and the cyber system, physical world and the cyber world. So in the physical world, the internet of things and internet and mobile internet, and in the cyber system, cloud computing, of course the big data plays important role. So why we need then industry 4.0? Of course, that is sharing economy. So centralization of economy based on a particular service is not a wise decision. That's why economy of the industry should be equally shared by multiple interconnected IoT devices based on their services. So we can optimize the services, save money. So the cyber physical system, of course, we can use in the healthcare system as well as industry, which we can say industry 4.0. So now I'm coming to the data. So for the since related to data, the topic is related to data analytics. As I have mentioned, the IoT devices and that is physical system, and then the cloud fog devices, those are the cyber system. Then we have the user layer, and we have the application layer, and the computation and the data analysis layer. As you can see here, so data is collected from different devices, IoT devices. Of course, comes to the fog or the cloud data centers, but important is prediction and analysis of the big data, because this data, the volume of the data, not only the volume, we can say it is the big data. Why it is big data? Of course, I will discuss it now. So the big data, we can say it could be web generated data, it could be healthcare medical data, it could be machine generated data, it could be business banking related data. And those data um, volume is huge. As you can see here from the smart city, uh, the time series data is around 62%. Then device information data, log data, contextual data, and operational data. There are different data, image, video, audio. There are several types of data generated from the smart cities. And this is just the survey of the normal survey of the data which are generated from the smart cities. So we can say the big data. So what is that big data? As we know, it is like 5 different components. That's why we say it's a big data, not necessarily only volume. It could be volume, it could be velocity, at what rate the data are generated from different devices, and could be the value out of that data. If we get the data and we don't know what is exactly the data is saying, and if we can't analyze and get the value out of the data, then big data is useless. So veracity of the data and variety of the data. So could be structured data, could be unstructured data. So this could be social media data, image, could be audio, video, could be industrial data, could be personal data. So different types of data, of course. So that's why we say it's a big data. Uh, and then, sorry. Okay. So this these types of data could be structured data. This big data could be structured data, could be semi-structured data, could be unstructured data. So if it is structured data, that of course we can store it in the database. And if it is semi-structured data, normally we store it in XML or in JSON format. And if it is unstructured data, such as comments, like, audio, video. So in case of structured data, there is a fixed schema, the fixed data type, and strict format. For example, like integer or float type. So it has fixed schema and fixed data type, such as the bank transaction. We can say structured data. We can store it in Oracle or MySQL database. And if it is semi-structured, such as longitude and latitude, so it is like GPS data, we can say it's a semi-structured data. And if it is unstructured data, is very difficult to store because it varies. There is no specific schema, no specific data type, no specific format. Data could be generated at any time of any format. So that is unstructured data. So if it is structured data, semi-structured data, unstructured data, we can summarize sorry, the activity for the structured data like bank transaction or GPS location for semi-structured data, or comment with selfie, this is unstructured data. And where to store, if structured data, normally we store it in Oracle or some standard database. If it is semi-structured data, we store it in terms of XML file. And if it is unstructured data, whether it is maybe sometimes maybe in XML format, sometimes in the database. So there is no standard format. Then how to store? We can store the structured data in table format and semi-structured data in terms of key and value format, and unstructured data could be in table format, could be in key format, could be in JPEG format, could be in text format. So could be in web, it could be web file because of the audio, video. And what to store? We can store like the transaction information, such as for the structured data, and location information for semi-structured data, and both text and image for the unstructured data. And when to store, that is end of the day. So it is, we can say it's a batch data. So the structured data is normally the batch data. End of the day, when any transaction is finished, normally we store it. And semi-structured data, each movement, that is, we can say it's a ad hoc data. And unstructured data is normally at any time we can store it. We need to store in the real-time basis. So it could be real-time data instead of the batch data. And this big data platform, if we say for the batch data, such as Hadoop, okay, or Works, so we have different cloud platforms. So if it is ad hoc data, such as Hive or Impala, or if it is real-time data, maybe Spark or Storm. So real-time data normally we can store, and mobility of a big data is um, so once we have stored it, then we need to analyze the data. It could be batch data, it could be ad hoc data, or could be real-time data. We need to analyze the data, and we need to predict, we need to classify. There are different applications that I'm going to also discuss it here. So the storing data is not a problem. So reading data is a challenge. So you can say like, how much time does it take to read 1 terabyte of data? If a simple, like a PC, 1 terabyte, suppose where it's a 1000 GB, then I have already calculated. So suppose we have 10 machines with 4 input output channels with each machine, and each channel can read 100 MB PS. Then we need 4.5 minutes to read 1 terabyte of data, and it will take several days if we have the huge volume of data, big data, such as 500 terabytes of data, then it may take 37.5 hours. That I have calculated here to give an impression that how the what is exactly challenging. So this reading data is also a bit challenging. So the data could be text data, could be image data, could be audio data, could be video data. So, and the image data, if the input data is image data, then we need the pre-processing and then analysis, then we get the output. So the data analysis of data, uh, why we need technology. That's why I'm mentioning here intuition versus technology. So human decides many real life questions based on intuition, and it is not based on any analysis. For example, what will be tomorrow's weather? We can guess, maybe today if it is sunny, maybe tomorrow maybe a rainy day or cloudy. We may guess, we may predict. Whether that prediction is correct or not, based on our intuition, we may predict. So that prediction may be accurate, but prediction may not be. So whether a bank transaction is fraudulent or valid, that we need to classify. So, or how many Facebook users are interested in traveling, study, or business, that we need to cluster the data. So in our real life also, we use data analysis for prediction, classification, clustering. However, sometimes it doesn't work. But the main problem is, if the volume of the data is so huge, sometimes our intuition also doesn't work properly to predict. That's why we apply artificial intelligence. As we know, in the data science, it's like there is some overlapping between data science. Not necessarily all data, uh, all data needs to be analyzed using AI. There are some data that can be used also using some statistical tools. Also, we can analyze the data. But nowadays, since because of the technology, AI is not a new area. uh, 60 70 years back, I will say, like 80 years back, I will say, AI is already there, but it was not popular because of the data. So when social media came into the picture, and the mobile users, so lots of data that is are generated in the real time basis, and those data needs to be analyzed, for which the human intuition or simple statistical methods may not able to uh, analyze and give the value out of the data. That's why AI came into the picture, and now it is very popular tool to analyze the data. So in artificial intelligence, I can say machine learning is very important part, as well as also deep learning. So I'm going just to introduce some part of this machine learning. So it is um, machine learning. It learns the input data. It could be labeled data or could be unlabeled data. And size of the input data plays an important role in learning machine learning algorithms and its accuracy. And in machine learning, the main thing is that we need to find the attributes by ourselves, the parameters, the features. The feature extraction is done by the user, so which could be error fraud. So sometimes there is, if some weather forecasting problem, I may consider 10 parameters in order to predict, whereas you may think maybe 10 parameters not enough, maybe 15 different parameters. So whether in the long run, whether your prediction is correct or my prediction is correct, that is different issue. But analysis of the data may vary based on the number of parameters. So we can use machine learning for prediction, for classification, for clustering, for categorization, and also different applications of machine learning we can for the optical character recognition. Suppose when I'm signing any document, then for optical character recognition, maybe machine learning can be used, spam filtering, weather prediction, and face detection, medical diagnosis, natural language processing, customer segmentation, fraud detection. These are different applications of machine learning. And it is, I have also summarized here, text-based sentiment analysis, prediction of equipment failures, that is in cyber physical system, prediction of new pricing model, so in management, in marketing, so network intrusion detection, that is in cyber security, pattern and image recognition, also for the criminal investigation, commercial data analysis in marketing, time series data analysis such as hat cardiological data, that I have also worked with this type of data, time series data, to predict the whether a patient is going to have the heart condition of a person is normal or abnormal. We use time series data. So there are different types of data, different applications of machine learning. However, deep learning plays very important role, and parameters, the different features are considered in this deep learning automatically. So user doesn't need to select the features for the analysis. And particularly, deep learning is highly essential, particularly I will say image data, audio data, and video data. So far as my research is concerned, I am focusing mainly on the deep learning to analyze the image data. So let us give very basic concept of this analysis image data. If you see this image, any image, we can have the horizontal axis and vertical axis, and we have different pixel values in each image. You can see there are different pixels. So we can say an image is nothing but a matrix of pixels having different pixel values, and that image could be a binary image, could be black and white, or could be grayscale image, or could be true color image. So accordingly, we have to design the deep learning model. So if it is binary image, a pixel that represents only one bit, 0 or 1, so we can have color values of each pixel 0 or 255. Or if it is grayscale image, that is 8 bit, 2 to the power 8, like 256 different values starting from 0 to 255. And if it is the colored image, we have three channels: red, green, and blue. So it will be 2 to the power 24. So there are different possible color values we can get. So we can get different color values, and that's why in deep learning we normally consider initially we consider three different channels: red, green, and blue. And I'm going to show how we normally train the image. So let us consider here, suppose we need to train the image. This is image of a cat. We can see this image, but computer can't. So what computer sees? Computer can see only the pixel values, the numbers. So if it is the image is of matrix M cross N matrix and three channels RGB, so we can consider it is M cross N cross 3. Okay, and this pixel intensity, these values, that number gives the pixel intensity at that point, and we can use that pixel intensity to train the image in artificial intelligence. So in this example, suppose this image is input image is 8. After sorry, pixelizing this image, we can get the corresponding pixel values, and then we can use those values either as the input layer in artificial intelligence. As we know, we have three different layers: input layer, output layer, and in between input output we have the hidden layers, number of hidden layers. So we can feed that input image to the system with a different pixel values such as x1, x2, x3, x4. I am giving here one example. Suppose input image is one zebra, and we have different layers that is in the hidden layer. As a, could be pooling layer, could be convolutional layer. So pooling convolutional layer, after that there is a flattening layer, and then we will get the output, which can classify whether it is a horse, a zebra, or a dog, or a cat. So there are different ways to classify the image. So this is normally the flow, that if it is the input image, there will be feature detector, that is the filter. Then we get the feature map. Then we use the ReLU layer. Then we get the convolutional layer. So that is the first part in the artificial intelligence. The first operation is the convolutional operation. So it's the step one. Then the next step is the pooling operation. So after getting the output from the convolutional layer, we can use the pooling layer and we get the pooled feature map. And then the third part is the flattening, and that is a one-dimensional array. Then finally, we will get the fully connected layer. So to predict. So here I'm giving some examples of convolutional operation of an image. If it is 1D convolution, I will skip it. If some of you want to know more about it, I will discuss later. And it is, if it's a 2D convolution, then you can see from this image, if this image is given here, you can see this is the image, the pixel value we may consider. Then this is the filter that I have mentioned. We need the filter. In each filter we can have several number of kernels. So then the convolutional operation is done. Then we get the feature map. So in this case, like if we have 3 channels like R, G, B, the convolutional layer, the convolutional operation is done, and using the different filters, and we get the output value as the feature map. So in this way we can get, if it is the input image, and this is the convolutional kernel, because the kernel value normally in the those who are working in this area, you might be knowing that we have different filters like Gloret filter. So if you are working in the TensorFlow or PyTorch framework, so you must be knowing about this. Then finally we get the feature map. So that I'm also talking about the concept of this convolutional neural network here. So this using the 3 channels, and if we have 2 filters, suppose filter 1 and filter 2, since we have 3 channels, we have 3 kernels in each filter, and we can generate like 2 neurons because of 2 filters. And then we can say this is some operations like from the red and the green and from the blue. Then if these are the filters, then from here we can get these values, taking the dot product between the pixel values and the associated weights. Then we will get in this way those values, and finally we get the feature maps like this. Suppose using filter 1 we will get feature map 1, using filter 2 we will get feature map 2. So thus we can use the convolutional operation to get the feature map. But important is the kernel values. So how to initialize the kernel values, that is important. Those who are programming in PyTorch or TensorFlow, maybe also you must be knowing, or you can think about it, how to decide different kernel values in order to get more appropriate predictions. So the motivation behind the convolutional neural network, as I have mentioned earlier, we have one array, suppose m cross n, and initially 3 channels, suppose, then m cross n cross 3. Then we have different inputs, and that is m cross n, and then there will be a global connectivity. So there is a difference between the local connectivity and global connectivity. The Convolutional neural network, deep learning, is based on the receptive field. Very important concept is the receptive field. So each neuron only, if it is local connectivity, each neuron only receives input from a small local group of pixels of the input image. I have shown you here. And how to achieve this local connectivity, the receptive field you can see here is a fully connected unit, and it's a locally connected units with 3 cross 3 receptive field. So sorry, the local informations are obtained, and the MLP have the different weights. Multi-layer perceptron have different weights among neurons. So based on the location of the object, such as face of the cat, the weights are corrected by the MLP, assuming the cat face will appear only in that location. So no local connectivity is established among nearby pixels. So we can say here in this image, the requirement of this is related to like the local. Suppose we are going to determine the paws of the cat. So maybe we should focus on the paws of the cat instead of the face. Suppose we want to detect the face of the cat. We no need to focus on the paws or body, so we need to focus particularly on the face of the cat. So we this is some comparison such as related to the local connectivity. And in case of the convolutional neural network, it is one of the variant of deep feed forward artificial neural network that works on basically two principles. Those are responsible for differentiating CNN from typical the multi-layer perceptron, the local connectivity, and weight sharing. So weight sharing is done and local connectivity is done. So it consists of, that's why in CNN it consists of several convolutional layers, pooling layers, and fully connected layers. And I'm comparing here the
మిగతా అవ్వట్లేదు. మిగతా దాంట్లో ఒక దగ్గర 2 zeros ఒక దగ్గర 1 zero ఎగ్జిస్ట్ కదా. అది మనం సింప్లిఫై చేసినప్పుడు
Shashidhar, please mute yourself. Dr. Shashidhar.
Sure. Okay. So I'm comparing here local connectivity with the global connectivity, and the weight sharing is also done. So finally we can get the result. So application of convolutional layer could be used in 1D, 2D, or 3D convolution, and we can also classify the image, so such as using the fully connected layer. So some part of this is like mathematically I'm explaining what is softmax in order to classify the image. If you want to know more about it, we will discuss maybe in the question and answer session. So then there are different network architectures such as functional and sequential convolutional neural network architecture to analyze the data, and we can have different parameters and hyperparameters in order to tune the artificial neural network, maybe in TensorFlow or PyTorch. So the image data analysis, we can use the computer vision task, could be classification, could be localization, could be detection, could be segmentation. If it is a classification, we need to classify whether the object is a dog or a cat. And if it is a detection, so we want to exactly detect where is the dog, which is the dog and which is the cat, and then where is the object and what is the object. So the where is the object, we can say it is like localization, and what is the object, it is the detection. So we may also detect multiple objects in the same frame. So we can also go for the segmentation, that is exactly to find where the object and what is the object. So we may go for segmentation. It could be semantic segmentation, it could be instance segmentation, also it could be panoptic segmentation. I have not mentioned here, but normally we focus on in semantic segmentation, that the stuff and the thing concept. So everything that we can include here, and the instance segmentation, very specific object also we can segment. So different object detection mechanisms are also there. I have mentioned here, that is, it could be 3-stage detector, could be 2-stage detector, or could be 1-stage detector. So why all these things are challenging in data analysis, why it is very challenging, I will show you here. Maybe I will ask the audience, if you are listening to me, you please see this image. Could you please let me know, this picture indicates what? This is picture of what?
Yeah, may I come in, sir?
Yes,
This is look like a duck head. When
it's
you
a
see
duck.
from the, yeah, duck
It's a,
head.
it's a
This
duck.
is
I
like
see.
the
Okay.
Doug, Battak.
Dog. D-O-G.
Yes.
Right? Dog.
Yes, sir.
Okay.
Yes, sir. Yes, sir.
Okay. Anyone else? If any other views? Huh.
Sir, it look like a duck and rabbit.
Duck and rabbit. I see. Okay. Duck and rabbit. Okay.
See,
So
Professor, may I come
yeah.
in, Professor?
Yeah,
When you
please.
see from left, to right, looks like rabbit. Duck spokes look like rabbit's ear. When you
Okay.
see from when you see from right to left, it look like duck. You have two
It
perspectives.
So
depend upon the sir. It depend upon the view side.
okay. So it seems you don't need
Is it a
AI.
bird?
So
It is a bird.
it's a bird. Okay. So some of you said it is a bird,
Mumble.
and one
Sometimes
of
it
the
is mumble,
professors
yeah.
says it's a dog, and another professor says maybe it is both rabbit and duck, D-U-C-K, right? So, you see, we have different views. That means it is a bit confusing. So I am analyzing also the medical image, normally the CT scan and MRI image for the brain stroke, heart stroke patients. So it is also very confusing for the doctors to say whether the patient has got stroke or not. The similar problem occurs, like here this image. So some of us, of course, you are correct that this image is a rabbit. So you can say the from this face, this side, this is the face of the rabbit, and these are the ears of the rabbit. Though it looks like a duck, looks like a bird. Okay. Another, let us say, could you please tell me what image is it? Whose image is it?
Little girl
A
and
young
woman.
lady and an old woman, both are there in this particular image.
Seems
It depend
like
upon the view side,
the
sir.
image that I have used is already analyzed by you earlier.
Yes.
Seems like that. Because it is a bit confusing. Most of the I have
Yes,
asked
sir.
in
We
different
studied
platforms.
in our.
Yeah, this is one young girl here, and also the old lady, right?
Yeah, Professor,
Okay.
before artificial intelligence finds out, our natural
Yeah,
intelligence gave answer.
yeah. That's why I
Yes,
told. That's why I told that you don't need AI, because your natural intelligence is very sharp.
very
It's a
true,
bit
Professor, very true.
better than AI. Okay. So this image is something bit confusing, right?
This
Like
I have
two
seen in
eyes.
most of the ophthalmologist, spectacle shop. I have seen this image.
Okay, okay, okay.
Yes, yes.
So that's why we need, it's a bit confusing normally for the stroke. So in this image, when I present to the medical professionals, normally I put the image on the right hand side, bottom right. So whether the image indicates it's a stroke patient or not. So it is a bit difficult also for the doctors to say whether it's a stroke or not. So that's why we normally use artificial intelligence to not only to predict but also to find the accuracy. also to detect, to localize. There are different ways. So sometimes our natural intelligence fails, and if the size of the data, the mainly is a big data, it is difficult to analyze the data, and time of prediction is also important. That's why we use artificial intelligence. So with this, I'm going to conclude that the huge research issues are there in the areas of Internet of Things, is for cloud computing, or in the cyber physical system, and also the applications of AI. So thank you so much. Um, I have concluded my talk. If anything, any question, please let me know. Thank you so much.
Thank you, sir. Thank you so much. Such a nice, wonderful session, sir.
Thank you so much.
Dr. Sau, I have one question.
Yeah, please.
When you discussed about intuition and technology,
Yeah.
so as AI models become more sophisticated, how can intuition remains a valuable part of decision making process?
Normally,
With the,
some small, yeah, for
yeah,
some
same thing. Like
small, yeah. Okay, please continue.
same question.
So, could you please repeat? Could you please repeat it?
Yeah, like when you discussed about intuition and technology, my question is, in the present scenario, as AI is given more significance, how can ensure that human intuition makes a vital role in the making process? What is the role of human intuition in the decision
Intuition.
making process? Yes.
The role of human nowadays, I will say, time was there. We were dependent on human intuition. Now the time has changed. We are dependent on technology. For example, now in India, of course, it's still a culture that we multiply something and calculate it. But nowadays, I find that most of the students, most of the people, they use a calculator. So instead of using the human intelligence, natural intelligence or intuition, now people more dependent on the artificial intelligence or technology, I will say. So anyway, I will say for small amount of data, we still need human intuition to decide, to predict, for small volume of data that we can find around. However, for large volume of data, for unstructured data, we sometimes the not sometimes some most of the times also human intuition fails. If it is unstructured data, huge volume of data, then human intuition fails to predict, to analyze. However, for small volume, the small volume of data, human intuition is still significant.
Professor Sahu, may I come in?
Yes, please.
To support your statement, to the HOD of Mechanical Department, Madam, I just posted one book in our, chat box. The name of the book is Nexus, and it is like
Yeah. Hello.
Recently, a wonderful book. I recently read this book. It is a wonderful book that directly.
Hello. Hello.
Sir, I believe the voice is breaking. Network issue, I believe. Sir, we have another question which is posted by Dr. Tulsiram, sir.
Oh, okay. Already posted?
Yes, sir. I'll just read it.
Okay.
Should
Could
I
you
read
please
it,
read it?
Yes.
Yeah,
Sir.
please.
How can big data analytics enhance risk management in the finance industry? especially with the growing complexity of global financial markets?
Oh, it's a very important, great question. So, no doubt, the AI plays very important role for in the financial market. As you say, it's a fintech. In fintech, the stock market, the share market data, is very unpredictable. So it is very difficult so far to apply the human intuition to predict which share can give better profit in the market. Just I'm giving one example for the share market. So not necessarily share market, also for different financial components, also maybe inflation or other things. I don't have much idea related to those terminology, but related to the financial data such as the stock market, uh, AI is highly essential, as so far the human intuition, as we have seen so far, human intuition doesn't work to predict the value. However, it can be compared. I'm not saying that AI can solve this problem, but people are still trying to predict with better accuracy so far as compared to the human intuition. That's why I will say AI is very important for the financial market.
There is another question, sir.
Yes, please.
Is any mechanism available for testing of the data so as to formulate an ideal decision?
You mean, is there any mechanism for texting
Yeah, testing, sir. Testing of the data.
or
How
testing?
can we?
Yes,
Yes,
for
sir.
testing data. Yes.
So that we can formulate an ideal decision.
Okay, it's a yeah, it's a very good question. I have also got some similar questions from different audience. There is no specific, there is no thumb rule so far, I'll say. For so far as my experience is concerned, there is no specific testing method. You have to, first of all, you have to understand the data. And after understanding the data, you need to think which algorithm, deep learning algorithm or machine learning algorithm you need to apply to analyze the data. This is the second step. First step, domain knowledge, understand the data. Second thing, that you may think which method you need to apply to solve, to get, to analyze the data. Then third thing, to test the data. You need the, of course it is which is produced like the practical data you need to compare. So there is no specific rule for the testing. Maybe you may think there are many training methods, that training methods you may think, such as for our medical image data, we have fixed some training methods, but testing methods there is no standard rule. You have to use your model, test with the currently available data, and whether our result can be good, better, or best. That the after testing we can say. There is no specific testing method, but there are different training methods to validate the result.
Okay, sir. Thank you, sir. Any
You
other
are welcome.
questions?
I have one more question, Dr. Sahu.
Yeah, please.
Yeah. So in your discussion, you said that AI is existing since many decades, but it is popularized because of social media and mobile usage. So in this connection, I just want to know, like, what future AI innovations can we expect in social media and mobile technology over the next decade?
Okay. The AI became, my point is, I just gave example, social media data and mobile data, just example. Not necessarily because of mobile data and social media data, AI became popular. Not because of that. I mean to say, because of the because of generating huge volume of data. Because AI needs to train the system using huge volume of data in order to get the better accuracy, the better output, the better testing result. So since we need huge volume of data, those huge volume of data earlier, there were no methods to generate. However, method like social media, people generated several volume of, that is several types of data, image, audio, video, by sharing with friend, etc., etc. So social media played very important role to get the data. And similarly, the mobile users data. That's why I told specifically the social media and mobile users. In the your question is for the future. So for the future, since we can't avoid mobile phone, since we can't avoid the social media, maybe we can get the better form. Who knows? There will be another form, such as we can say, you see the deep fake, okay, and also the meta. So the metadata. So there is several types of data will be generated in future, more data. That's why we need the components, the methods to analyze the data. That's why AI is very important. So AI has great future. Maybe people misuse it, but AI has great future, as we can't avoid data because of the current trend in the society market. That is the huge volume of data generated in the society. So AI has great future, as we need to use it as a tool to analyze the data.
Thank you. Thank you.
You are welcome.
Yeah. Any questions from the participants?
Sir, there is one question posted by Dr. Neeraja ma'am.
Okay.
She's asking, can AI predict the forthcoming health issues in advance to be cautious about our health? If so,
Sure.
to what
If so,
extent can we
yes.
trust the information as the inputs are given by humans?
Okay. We have already developed one device using AI, that is a locket, like a pendant. So it should touch the screen and the skin, human skin, for 1 minute. Then it can predict the condition of the status of the brain. It won't give an exact value, but my brain status, whether it is in normal condition or in moderate condition, like a warning condition, or it's in the red. So we have green, yellow, red level. Similarly, condition of my heart. Similarly, my sugar level. So such as we say normal up to 100, maybe 100 to 120 is moderate, and above 120 maybe it is alarming. So then in that case, like it's a green, yellow or red, that also can predict. There are several devices also available in the market that they use artificial intelligence to detect the condition of the health and also can predict it.
Thank you, sir.
Madam, one second. May I come in, Professor? One last
Yes,
question.
please.
See, you used one word called prediction. So it is it is not exactly a question. It is a curious, expectation. So prediction happens after it happens. For example, when we say prediction of early cancer detection means after the cells are accumulated and formed as a cancer, it will predict it, reflects on us. Is my statement right or wrong? I do not know. So prediction means how exactly the AI will support in terms of prediction. That is what my curious question is.
Okay. Prediction means what is going to happen. normally, if from the literature point of view, if we say that is prediction means what is going to happen. So suppose today is a rainy day, tomorrow will be sunny day. Of course, we apply human intuition and we can say, look at the sky and we can say whether tomorrow will be sunny day or not.
No,
But
I understand, Professor Sahu.
yeah,
Humans' expectation and prediction both has its own length of understanding and meaning. So, in that sense, as a curious question, just I posted this. Yeah.
so particularly in the healthcare, the prediction means all cases AI doesn't. AI is not applied only for prediction. AI also is applied for classification. AI also is applied to detect something. AI is also applied to localize something. AI is also applied to differentiate something. So prediction is one task of artificial intelligence, such as weather forecasting, stock market, the financial data based on financial data analysis. Prediction may be stock market of share A. So suppose the share price of A today is 10 rupees. Tomorrow it may be less than 10 or more than 10. That will be prediction. So AI can be applied, but not necessarily AI is applied only for that purpose.
Yeah, thank you, Professor Sahu.
Yeah.
If I am the luckiest person who has that, what we call it as data set, and as well as we call it as what we call this, what they call it as, I do not know exactly because I belong to mechatronics. Algorithm. I got the point.
Yeah.
If I am lucky enough in the world to have the algorithm of predicting the stock market, I am the richest person, better than Elon Musk and even other topmost richest person in the world.
Thank you.
So just in a lighter note, I'm telling. Don't take it in the other way. But I really enjoyed your session. Thank you very much. Yeah, thank you very much, sir.
Thank you.
Sir, last question.
Yeah.
What role does AI play in addressing global challenges such as climate changes or poverty reduction? So, can I know, sir?
You see, there are some problems made by the human being themselves. So AI can predict, can alert, can suggest, but AI, such as suppose global warming. So AI can suggest you how global warming can be prevented, but AI cannot change the global warming. For example, similarly, the behavior of the people, AI can predict my behavior, your behavior, but cannot change my behavior. This is my personal feelings.
Okay, sir. Thank you, sir.
Yes. Yeah.
Thank you, sir.
Thank you.
At the
Anything
outset,
else?
sir,
Yeah.
there are no more questions, sir. So, can I propose the vote of thanks?
Okay.
By all
With your
means,
permission,
madam.
sir.
Yeah, by all means.
At the
Wonderful session.
outset, at the outset, I take the
Thank you.
privilege of proposing vote of thanks. The depth of knowledge you have imparted today, sir, it talks about your extensive research experience in the area of AI, cloud computing, and data analysis. The practical applications that you have highlighted, they have definitely broadened our knowledge, and it will help us to explore the possibilities of improving efficiency through data-driven approaches. We are especially grateful for the way you have outlined how industries can significantly benefit from AI-powered models for ensuring smoother operations and enhancing their efficiency. Thank you so much, sir, for being there.
Thank you so much. It's my honor to deliver the talk.
Thank you, sir. I would also like to extend my thanks to all the participants for their patience and time. And I also thank the Department of SMS, along with all the coordinators of this FDP for the success, as well as for planning such a session through which we can gain more informative insights from our speaker today. Thank you so much.
Thank you so much. Thank you.
Thank you, sir. Thank you, ma'am.
Dr.
Thank you.
Sahu, thank you so much.
Thank you. Thank you so much.
Wonderful session. Thank you.
Thank you. Thank you. Thank you. So, okay. Thank you so much.
Yeah, thank you.
Thank you.
All the participants, please fill the feedback and attendance form.